Hello, my name is Roman. I'm from Ukraine. I've been building online companies for the last 15 years. My education background is AI, and I'm Chief Strategy Officer for Sensay. Today I'm going to talk to you about what we're doing in Sensay, how is it related to future of AI technologies, and what Sensay is about. So in Sensay we are doing infrastructure for human AI replicas. And now with advancement of AI technologies and tools like ChatGPT and other large language models, data, especially human data, becomes very relevant and important. Large language models work in a way that basically it's an algorithm that predicts next word that comes in a sentence with certain probability, and then higher probability it puts the better chances that the sentence would look good for human reader. For that, large language models, they need a lot of data, and all large language models that currently exist, it's ChatGPT, Claude, Anthropic AI, and others that you're probably familiar with, they need a lot of human data to be trained on. So all data that's currently on internet is already being used by these large language models. So ChatGPT 5 is already being trained on synthetic data, which is artificially created data, which is not generated by humans, but generated by algorithms to be used for training. So there is limitation to the data that's available on internet and generated by humans. So in the future, the data is a crucial and critical element to increasing the quality and potential of large language models. So that's very important. Algorithms, they won't make too much difference in the future. But data, what is important? So fundamentally, hardware and data, what matters in terms of competitive advantage in AI, large language models, and AI business in general. So what we are doing in Sensay, we're creating infrastructure to capture human data in a seamless manner, and then allow people and AI agents to use the data for different purposes. So one of the things that we are focusing on in Sensay right now is bringing AI human replicas, AI agents into business sector to increase efficiency and data management processes in large, medium-scale organizations. So we are creating systems that allow to capture the data from different sources, such as messenger system, email systems, internal communication systems, CRMs, data management systems, traditional data management systems. And we store that data in a secure, private, encrypted manner, and then we allow organization participants, employees, and other AI agents to utilize that data, which saves a lot of time. People don't wait for reply from their colleagues. Instead of that, they can talk to an AI agent and get all required information 24/7, which saves a lot of time, thus saves a lot of money. So that's one of the main angles we're focusing on right now in Sensay. So what are the ways humans can interact with AI agents? Fundamentally, it's text-based data. Large language models, they base on text data. So everything that is being used as an input and output for AI, as we know it publicly right now, is like as ChatGPT and other language models, is text-based data. So what we're doing in Sensay, we're using chat-based interfaces to allow people and machines, other agents, to interact with our replicas using text-based interface. Other than that, we will introduce ability to interact with voice. You can just exchange voice messages, or to add your agent, your replica, on the team call, and then agent would be able to interact with other participants in the voice-based interface and video-based interface, with replica being able to reflect emotions, personality, gesticulations, and other personal and character-specific features. Now I'm going to talk a bit about Web3 and how we use Web3 technologies in Sensay. So what are the two fundamental features of decentralized AI? Fundamentally, to create a truly decentralized AI, which is permissionless, censorship resistant, and can be accessed in a trustless manner, you need two elements. One is data, decentralized data, and second one is decentralized hardware. Decentralized hardware is being addressed by market players like Render and Aether. Probably you're familiar with them. And decentralized data is something that we are using and addressing in Sensay. Imagine a situation where you have a public person, it has a lot of followers, huge amount of audience, and then currently there is certain prevalent narrative, social or political narrative. And then he creates his replica, but then in the future that social or political narrative can change. Thus, his replica, if it's hosted on traditional Web 2 infrastructure, it can be censored in the future. By using blockchain technologies, it allows us to keep that data that is related to the replica in a persistent manner using decentralized data storage and provide access to that data with blockchain technologies, so that replica and that data can persist over generations. So whatever social and political narrative is in the future, that replica becomes available. So it's a very interesting use case for quite a wide range of applications. It's a still niche application. It's probably majority of people, they won't need it, but then there are some very censorship resistant sensitive applications, which is very good use cases for these technologies. So that's what we're using blockchain technologies in Sensay for. Our end goal in Sensay to achieve digital immortality. So what is digital immortality? Digital immortality is pretty much a concept that was coined a while ago, decades ago, and it's been covered widely in science fiction literature. And it's basically transferring knowledge, memories, personality, and all fundamental information about human being into the digital realm. So it can persist indefinitely in digital realm. Fundamentally, to achieve that from physics standpoint, you need to capture the entire information that human brain stores. So on a physical level, it's all electrical signal, biochemical relationship. It's basically like capturing molecular structure together with all the electrical dependency, electrical relationship in terms of how neurons interact with each other. So it's a lot of information, and it's basically capturing information on atomic level. So probably sometime in the future it will be possible to accurately capture and transfer the entire human brain snapshot in a digital realm, but we need some scientific advancement to reach that goal. Probably AGI would assist us with that. What we're doing with Sensay now, we're doing it on the level of information, text-based information, voice, videos, pictures, any information that human being can store, recall, reproduce. So, and for that we're using the infrastructure that we're creating in Sensay. So we are capturing, storing, and reproducing human knowledge, memories, experiences to represent personality as accurate as possible. And for that, the best way to capture that knowledge right now is devices like mobile phones or computers. It's basically human brain interface. It's a computer brain interfaces that humans use most efficiently right now, that we can also use to capture all this information that human inputs while using them. Interesting concept that majority of the information that is generated on internet over time, over basically generations, all the books that's been written, all the information that's available on internet is generated by vocal minority of people. So non-vocal majority of people, for them, all the majority of their expertise, information, memories, knowledge is either being lost or captured very fractionally. So it's basically some interactions with their family, with their co-workers, with some documentation that they create, but that's only a fraction of their expertise. And their expertise is not necessarily inferior to the expertise of people who are vocal, social media, creating materials, creating books. So capturing all this data, whether it's personal domain or professional domain, corporate domain, where there's the same problem. Majority of people in corporate settings, they don't share information actively unless we incentivize them to do so. For example, with Sensay, What we are planning to do is capture this information from public domain seamlessly while people doing their day-to-day tasks, they live in their day-to-day life. We're capturing all the information that they input via digital devices, and we're preserving it, store it in a secure, encrypted manner. We're able to share it, or we're able to make other agents and AI system to use that for training, which is very valuable. So to sum up, in Sensay, we're capturing human-generated data. We're storing it in persistent, secure, encrypted manner. And that's the most obvious, widely sought for competitive advantage for AI companies. Human-generated data is something that will give competitive advantage to AI companies in the future. Not algorithms, not technologies related to machine learning, but the data. The data that is something that is like absolutely necessary to improve quality of AI systems. Human-generated data, especially because all the large language models, they trained on human-generated data. So until we have new generation of AI systems that would base their inference on fundamental laws of nature and physics, which is current research for large players like OpenAI and others going to, we will have prevalence of large language models, which base their inference on human-generated data. In Sensay, we create infrastructure to capture that human-generated data and store it in a secure, permissionless, persistent, and encrypted manner to be used by other people, AI agents, companies, businesses, potentially AI training. In this age, data is most valuable resource for AI, and in Sensay, we are creating infrastructure for data. So that gives us competitive advantage for the next 5 to 10 years until we get to next generation of AI models. Thank you very much for your attention. It was a pleasure talking to you.